Welcome to this explainer. Today, we're taking a highly structured look right under the hood of what's honestly a truly vital tool in modern tech infrastructure. We are unpacking ECD 3.7.0 beta.0. If you spend any time working with, or really even just thinking about massive distributed systems, you know that keeping everything synchronized is a monumental task. The complexity scales exponentially with every single new node you add. So today, we're going to break down the exact mechanism that keeps all of that complexity manageable. Let's dive right in by asking the ultimate hook question. How does a massive cloud application actually remember everything? Imagine a global streaming service or an e-commerce giant right in the middle of Black Friday. You've got thousands of distinct, independent computing components spread out across a vast, geographically distributed system. The stakes of managing the state of that data are astronomically high. If those microservices lose track of their configuration, if they forget who's supposed to be doing what, or if they simply can't find each other over the network, the entire system just crashes into total chaos. A tiny, localized hiccup cascades into a massive global outage. To prevent that, a distributed system absolutely needs a central, flawless memory bank to act as its source of truth. So here is our roadmap for today. We'll cover 1. The brain of cloud computing. 2. What is etcd? 3. New in version 3.7.0. 4. Under the hood improvements. 5. Real-world applications. And finally 6. Upgrading to the future. Let's kick things off with Section 1, the brain of cloud computing. ECT is exactly that reliable memory bank we were just talking about. It's formally defined as a distributed key-value store. Let's briefly unpack what that actually means, because key-value store sounds a little abstract, but it's incredibly elegant. Think of it like a massive, highly efficient dictionary. You have your key, which is a unique identifier, and your value, which is the specific configuration data or state tied to that key. Instead of some complex, tangled relational database, a key-value store lets a system instantly look up a specific state without any heavy lifting. But the absolutely crucial word here is distributed. ECT doesn't just live on one single server. It's replicated across a whole cluster of machines. It uses a really sophisticated consensus algorithm called Raft to ensure that even if several of those machines lose power or get disconnected or just completely fail, the remaining machines still hold the exact unified truth of the system's state. There is no split brain scenario here. There is zero ambiguity. When your application scales up and gets wildly complex, this mechanism is the resilient anchor that ensures absolute consistency. And understanding that core purpose naturally leads us to how this architecture was built in the first place. Which brings us to Section 2. What is etcd? Functionally, etcd rests on a few core technical pillars that really define its identity. First off, it's a completely open-source project hosted by the Cloud Native Computing Foundation. And that's not just a trivial licensing detail, right? Being open-source means it's constantly stress-tested, audited, and refined by a massive, diverse community of top-tier developers who are running it in some of the most demanding production environments on Earth. Second, it's written in the Go programming language. Now, why does the language matter? Well, Go was specifically designed by Google to excel at concurrent processing and network systems. By leveraging Go's lightweight execution threads, which are known as Go routines, etcd can handle thousands of simultaneous read and write requests every single second without breaking a sweat or hogging your system memory. It is highly efficient by design. This combination of an open-source model and a high concurrency language results in a tool that provides brilliantly simple yet wildly efficient data management at almost any scale. And that rock-solid foundation is exactly what let the team push the boundaries with their newest release. All right, let's pop the hood. Section 3. New in version 3.7.0. This beta release rests on 3 massive pillars of improvement: improved performance, enhanced security, and new APIs. And we're not just talking about incremental tweaks here. These represent a deep evolution of the platform. Let's dive into improved performance first. In really congested environments, previous versions could sometimes experience latency spikes during massive data snapshots. Version 3.7.0 heavily optimizes the memory footprint and the read-write speeds, ensuring that even when a cluster is under heavy, sustained load, etcd doesn't become the bottleneck. It handles large state changes with significantly less friction. Next up is enhanced security. In an era where configuration data is often a prime target for malicious actors, 3.7.0 introduces way more robust security parameters. This includes tightened TLS handshake processes and improved authentication mechanisms. It's essentially wrapping your critical cluster data in a much stronger cryptographic vault. Finally, new APIs. For the developers who are actually wiring these systems together, the updated APIs offer so much more flexibility. They streamline the watch mechanisms, which are the processes where a client listens for changes in a specific piece of data, making the communication between the central memory bank and your sprawling microservices much more fluent and way less resource-intensive. And these high-level features are directly supported by some pretty intense, granular code changes. Moving right along to Section 4, Under the Hood Improvements. Pushing past the major feature headlines, the real unsung heroes of the 3.7.0 beta.0 release are the systematic bug fixes. Previous versions, just like any complex software running at a global scale, faced highly specific edge case issues. For example, under very specific network partition scenarios, you might have seen some slight fleekiness in leader election. That's the process where the nodes vote on who's currently in charge of the data. Version 3.7.0 beta.0 aggressively targets these exact vulnerabilities. By shoring up the raft consensus mechanics and eliminating minor memory leaks that could build up over months of uptime, the developers have vastly improved the overall reliability metric. The upgrade literally transforms a highly stable system into an incredibly resilient one. It's all about ensuring that when a server rack randomly loses power at 3 a.m., the cluster just reorganizes itself seamlessly without dropping a single configuration update. This obsessive focus on under-the-hood stability is exactly why this tech is trusted to run the most important platforms in the industry. Let's look at where this actually lives out in the wild. Section 5, Real-World Applications. Out there in the real world, this tool sits at the absolute center of the cloud computing ecosystem, specifically dominating 4 key areas. First and foremost is Kubernetes. etcd is the primary indispensable data store for Kubernetes. Every single pod, node, and deployment state within a Kubernetes cluster is stored right here. Without it, Kubernetes literally has no idea what it's supposed to be doing. But it extends beyond just Kubernetes into broader container orchestration. Any system that needs to spin up, tear down, and manage thousands of software containers relies on this consistent memory state to track operations. Then we have service discovery. Imagine microservice A needs to send data to microservice B, but microservice B is constantly moving to different IP addresses as it scales up and down. etcd acts as the dynamic directory. Microservice A simply asks, "Hey, where is B right now?" and gets an instantaneous, accurate answer. Lastly, configuration management. When a DevOps team needs to push a crucial configuration change, like an updated rate limit, to 5,000 servers simultaneously, they don't do it one by one. They update the value in etcd, and all 5,000 servers instantly read the new configuration. It really is the central nervous system of modern infrastructure. With its widespread application so clear, the question becomes how to safely integrate these new updates. So, how do we get there? Section 6, Upgrading to the Future. If you're getting ready to make the jump to this new version, you need a precise and cautious plan. First, it is absolutely critical to follow the official step-by-step upgrade and migration guide. You really cannot just overwrite the old binaries and cross your fingers. Second, strictly implement the recommended best practices. This means taking a comprehensive snapshot of your cluster's data before you even think about starting the upgrade process. It also means thoroughly testing the new version in a staging environment that actually mirrors your production traffic, making sure your specific client apps communicate flawlessly with updated APIs. And third, utilize the troubleshooting guide for common issues. I'm going to offer a very practical reminder right here. This is a beta release. The features are incredibly powerful, but anyone deploying beta software directly into production knows to keep that troubleshooting guide very, very close at hand. Honestly, maybe tape it directly to your monitor. Be methodical, validate your backups, and for sure test your rollback procedures before you begin. We've definitely covered a lot of ground today. We've explored how a distributed key-value store prevents systemic chaos. We've examined the massive performance and security leaps in version 3.7.0, and we've seen exactly why this tech is the beating heart of platforms like Kubernetes. So I want to leave you with this final thought to chew on. With etcd 3.7.0-beta.0 powering the future of cloud computing, is your infrastructure ready for the upgrade? Keep learning, keep building, and until next time, stay curious.